right, everybody, I want to show you how to do the Desmos activity that's on today's agenda. So today is November 24th, Tuesday, last day before Thanksgiving break. And on the agenda today, like it says, we're going to continue focusing on solving equations. But in today's lesson, it's going to be equations that just have variables on both sides, meaning there's a letter on both sides of the equal sign. So to get into this, you'll click on number 3 on the agenda, and then you'll click on the link that's inside of that activity. And then if I will get it, if it wants to let me. There we go. So here's what the first example looks like of this activity. So you can see we've got 3w plus 6 equals 4. Now, we have been doing this in class where we've actually, instead of the 3w, we've written 3 triangles, or we've shown that it's actually 3 w's. But what I'm going to do today is I want to get into having you practice writing the way a high school student would write. A high school student recognizes that this is 3 w's. That 3 isn't there. It's actually the same thing as www, not World Wide Web. And this is not 4w, it's actually www. But the high school way, they don't write as much as we have when we've been drawing or spreading things out. They just know that 3 w's, they're picturing 3 w's in their mind. So to start solving this, I need to remove the w's from one side of the equation. When I do it, I always pick with the smaller value. 3 is less than 4, so I'm going to take off 3 w's from the left side. Now, whatever I do to the left, I also have to do to the right. So I'm going to take 3 w's from there too. The nice thing about that is these go away because 3 minus 3 is nothing. I don't need to write it because I'm writing less, not more. And I know that 4w minus 3w is the same thing as 1w. Now, I didn't touch the 6. It is still there. So what I have now is 6 is the same thing as 1w. In algebra, they recognize that if it's 1w, they only need to write w. So once you get down to 1w, you have found your answer. So how we type that in is we say w equals 6. And then explain our thinking. Over here, I've shown my work. I just need to describe what my work says I did. Well, I subtracted 3w from both sides. That left w equals 6. Then I would hit submit. So if you need to, pause, get this jotted down in your activity, and then let's go on to question 2. Here's slide 2. Slide 2, similar thinking. I have c's on both sides of the equation. Right here, this is 8 c's. So it's the same thing as having 8 of them written out. This side is the same thing as having 5 of them written out, but that's writing a lot. I don't want to do that. I know I would scribble out 5 of the c's. So I write that algebraically by just subtracting 5c. If I do it on the right side, I also have to subtract 5c on the left. 5 minus 5 is nothing. I did not touch that 21, so it gets brought down. And over here, I recognize that 8 c's, if I take 5 of them away, I'm left with 3 of the c's. Now, this is the same thing as 3 different c's. So I'm splitting that 21 up into the 3 groups. 3 times c equals 21. The inverse operation of multiplication is division. So I would divide both sides by 3, and 21 divided by 3 is 7. So I know that c equals 7. So I'd come up here, type that in, and then explain. The first thing I did is I subtracted 5c from both sides. Then I divided both sides by 3, and I said 21 divided by 3 equals 7. I'm going to do one more example with you. This example is going to show something we haven't done yet, but still works exactly the same. If I look at both sides of this equation, I see a couple things. First off, this t right here doesn't have a number. It's the same thing if there was a 1 in front of it. So this is the same thing as 1t. Over here I've got 7, still plus, but right here I've got a minus. Still going to do everything almost exactly the same, only I can't subtract 14. I would have to undo subtraction with addition. Let's get rid of the t's first. I always start with taking the smaller value of variables off. There's only 1 over here. So I'm going to subtract 1t from that side, and I'm going to subtract 1t from this side. I didn't touch that 10 yet, so I'm going to bring it down. I know that 7t minus 1t leaves me with 6 of them. And I did not touch that 14, that minus 14, so it gets brought down. Now, I need to get these t's alone, which means I have to move this negative 14. That is the same thing as subtracting 14. A negative and a subtraction are the same. So I undo that subtraction 14 with the inverse of subtraction, which is addition. So to cancel those out, I'm going to add 14. When I do that, negative 14 plus 14 is 0. That's why I did that. I wanted that to be 0. Now, if I added 14 on the right, I have to add 14 on the left. That leaves me with the 6t here, and 10 plus 14 is 24. So now 24 into 6 of what? So this says 6 times what is 24. I undo multiplication with division. In algebra, they show division with a fraction. Don't panic that I wrote a fraction. 6 divided by 6 is 1, so that leaves me with t. And 24 divided by 6, because I divided by 6 here, I have to divide by 6 here. 24 divided by 6 is 4. So here's what I'm going to write in my answer. Then to submit and explain my thinking, first, I subtracted 1t from both sides. That was step 1. Step 2, I added 14 to both sides to get the 6t alone. And then last, after adding 14, I divided both sides by 6. And I said 24 divided by 6 was 4. So that's how you're going to do these. Similar idea to what we've been practicing, except instead of, and if you want to write the shapes and squares out, you totally can. I'm just trying to show you a way to write less. What you need to do, what we did in class today, was get through examples 4, 5, and 6, and then we'll finish the rest of this when we return from break on Monday, November 30th. If I don't see you before the holiday, happy Thanksgiving, and I'll see you after break.